This time on Captain Chaos's laboratory, we're going to be working on the Lemax Palace Ballroom from, I think, 2003. This is kind of how it arrived. When I say kind of, it was in this package, but as soon as I removed the foam, the entire bottom fell out. The glue that holds this inside as completely broke free. I'm not sure if it was shipped that way or if it's just the heat in shipping or the glue's not sticking. There's a piece of it right there. And so as soon as I took it out, I caught the bottom, so it didn't just drop and fall. But that's kind of sort of how it showed up. So the problem with this is it doesn't work. So, weird, but that's why it's here. So this wire goes to the lights that are up inside here, and a couple of them have come unglued. I'm assuming it's been worked on before because this glue is absolutely clear, and usually something of this age, the glue is going to be yellowed. So it's the style, the old school, where the wheel and the power goes right there. It's 4.5 volts. And when I go, I don't get a light in here. I don't get motion. So it's going to be one of a couple things. Bad switch, bad motor, bad circuit board. And when I say bad switch, it also could be a broken wire on the switch. 99, or probably less than that, about 90 some odd, 5 maybe % of the time, it's usually a bad motor. So we're going to start there. So technically, the bottom should be glued in, and it should still be, well, we do have a broken wire right there. That might be the problem. And you would remove these 4 screws. So let's start there. Oh, this kind of makes it easier because I don't have to fight with the porcelain house and potentially break it or snap off one of the spires or chimneys. Four screws are out, and all that's going to do is remove this outer ring, which technically doesn't do anything since it's not in the house, but that's how you would normally remove it. I don't know what this white wire goes to. There's the motor. There is a screw in the center of the dance floor. Looks like the dance floor is pressed onto the center peg, which is square. So I'm just gonna, there we go, pop it free. There's the gears. You can see they're covered in grease that allow this to rotate. I'm gonna set this over here out of the way. The characters are a hard resin, and the disc is plastic. There's 3 holes that are full of goop, which I'm assuming are Phillips screws. So I'm going to use a deeper screwdriver. It doesn't fit. There we go. It does fit. Stay in this slot. Bottom is just the basic bottom, and there is our mechanism. And this is the old school one that has the miniature gearbox that's actually attached to the motor right there. They're kind of a pain when you break a gear in there. They're hard to find. So I'll use some magnifiers and take a gander. They don't look bad. So let's see if we can figure out where this white wire goes. I'm assuming the white wire goes to the motor, since the motor only has one contact, and that's it. I do see a broken brown wire right here. Right there. Or is that gray? No, it's brown. So no idea what that goes to. There's also a broken green wire directly below it, all inside this glue, so I'm not sure exactly what that's for, unless it was these wires initially and they were resoldered, which is a very high likelihood, since again this glue is clear, and if you can see, all this other glue, oh, you can't see the bottom, is yellowed. Let's take a look inside here. Wires look okay. Might have to voltage test and see if we're getting power to the circuit board, because motor's disconnected, so if it's a bad motor we would have power. That could be part of the problem. This capacitor right here is exploded. That guy right there. So electronics usually like to have all their components in good functional order. Before I go any further though, since the wires are still attached, I'm going to take a picture of the circuit board just in case any of these wires decide to break off, since they are 20 years old and they don't use the greatest solder. There we go. So I'm going to try and prop this board up so we can zoom in and you can hopefully take a see or look at this capacitor. Let's move it over there. So right there. The guts of the capacitor have blown out the bottom. And that's not how it's supposed to work. You might be able to see it slightly better. This capacitor is a 220 microfarad at 6.3 volts. So I need to look at what I got and see if we can get this thing swapped out. Back the camera back out. Look at that, first time, didn't go the wrong direction. Alright, but I want to test the motor real quick. And I'm going to use my power supply. I'm going to set it for 3 volts. Just in case this motor is underpowered from the circuit board. There is no voltage stamped on the top, but 3 volts guarantees that, you shouldn't burn it up. So it is turning. I'm assuming it's turning the right direction. It's not fast. That's 4.5 volts. That's 3.5. So, motor does work. It's good to know. It's got a bad solder joint though. You can see that. Especially since the solder just broke off. We'll fix that. Not a problem. Where's my capacitors? There's your lights. Lights. Connectors. Over here. So, one last time. 220 microfarads, 6.3 volts. It's going to take me just a moment to see what I got. 1,000, 1,000, 1,000. Oh, thousands. $470. That's these big guys. 300. 100. I hate to say it, I might be out of 220s. On a capacitor, it's important that you try and get the same microfarad, because that usually it controls speed. But what's also important is the voltage. Like this one's 12 volts. I could use this one, but it's the wrong microfarad. And this one is 10. 82, 300. One of these technically could work, but it wouldn't fit inside. A little on the big side. $330. That's an inductor. 70. $220 microfarads. So that's a little bit larger capacitor, but it's the right power, so I do have one. It's also 25 volts. It should still work fine because the voltage can be higher than the power. You never want it lower. And capacitors are polarized, so it says negative. So the pin here is the negative. If you put them in backwards, they either don't function or they explode. So gotta be careful with those. Some circuit boards are labeled, some circuit boards aren't. So it's always good to know which direction it's sitting in originally. Currently, the negative is facing me. this way. I'm assuming that's the correct way. Once this is taken out, desoldered, it might have it underneath on the board. It might be printed with a minus or positive. Usually it has the minus. I'm going to put a little flux on there so I can desolder this real fast. So normally when a capacitor goes, it blows the end. But, so you can see this one, if it'll focus and I stop moving so much, is kind of flat. And then this one, you can see the bottom's all bulged out. Shouldn't be like that. That's no good. On here, it does not have the symbol of negative or positive. So we're going to put this in the same way the other one was taken out. Trying to line up the holes. The spread is different than this one. There we go. So the holes are lined up. There's still some solder in the holes, so I'm going to just heat up the solder that's in the holes to get the capacitor to drop through. And then if it needs, I'll add fresh solder. Like that. So, there we go. Hopefully it's below the standoff so it doesn't rub on the disc. If it does, we'll desolder it and then put the capacitor over here with a pair of wires to jump it over. Right now I just want to make sure this thing works. It's possible that it could have blown the board when the capacitor blew, or if the capacitor was changed, it could have blown the board. Meaning changed to the wrong capacitance. If that's the case, you can still make this work, it just won't have any sound. You can just wire it so that the switch turns on the motor and the lights. Now I'm going to fix the solder on the motor. I'm going to touch up the other one. Just make sure we got a good bond. Like that. And then these bare wires that are glued on, that are just twisted and glued, I'm going to solder those real quick just to make sure that we have a good bond as well. Hopefully these aren't the problem. I'm not going to solder on the white wire for the motor at the moment, so I just want to see if we get sound and light. All right. We got light. Look at that. No sound though. Let's solder that last wire on the motor and see if we got motion. It is very possible that when the capacitor blew, it took out the sound part of the blob chip, because it comes right off of the blob chip, which is right here. On most of the circuit boards I find that have a blown capacitor, the sound will never work again, because when the capacitor fails, it overloads the leg that comes off the blob chip. It usually doesn't damage the amplifier chip, which is this guy right here. But this one gets damaged and then you have no sound. It's more common than not when you lose your capacitor, the big one that comes off and goes over to the sound chip. You can kind of see the two tracks right here, and the one track that comes off the capacitor goes right into the amplifier, so you know it's to the sound. The motor generally has a capacitor across the back, which reduces the noise for the motor. This one is for the sound chip, just like this one right here, which is itty bitty, and I'll zoom in a minute. I want to get the motor wire resoldered first and see if the motor actually turns under the power of the circuitry. There we go. It worked for a minute, and we lost everything. Maybe the motor is too much of a load for the unit. So, find out. Take the wire back off and see if it starts up again. Well, lights turned on for a second. And we lost the lights again. I don't smell anything. Lights are still on. There's two here, and then there's the ones inside the house that are on. I can see them through the windows. So if I move it, I lose my lights. Right there. One of these connections might be bad. So I am going to try and give it a better solder connection than I did. I'm going to do both of them. I'm going to break them free from the glue, so that way I don't worry about melting the glue or melting the plastic that's glued to. And then use some flux to help penetrate the ball of wire. Whew. Stuff is horrible. This one, I can leave the wires glued, because the wires are glued, not the actual exposed or stripped part. The flux smells bad, and so does the solder. It is toxic to breathe. That's why I keep moving my head and blowing against it. I have an exhaust or extraction fan, but unfortunately, when it's on, the camera picks up the noise horribly, and it's hard to hear me over it, as well as it's really hard to edit out, which is why when I go to when this finally gets moved to its new area, which is about 3 times as big, it'll have more ventilation, and I can have a fan going that's quiet to move the air. So I don't have to have a loud fan, because there's actually 3 fans around me to help blow and suck out fumes. But on camera, they're really tough. But there's one over there, there's one right above me, and there's one over there, which is the exhaust fan that has I'm supposed to put right here while I'm soldering, and it blows it right next to me, so it doesn't really matter. So I still lose my lights if I rotate this too far. Why am I losing my lights? So it's this wire, my incoming switch. So, do I have a broken one or a bad solder joint? I think there's a short. There's a piece of something stuck through the solder connecting to the wire. That's not supposed to be there. The wire looks okay. solder joints, well, they're Lemax, so they're there. That was the problem. There was a piece of material stuck to the bottom that was shorting it out. But just to make sure, let's put her back where she's supposed to be. This side will have to get glued down because the standoff is broken. I'm going to screw the one side that's still set. That. No, I am still losing light. I think I got a broken wire in this bundle. So what I do is if you hold your finger, that means nothing past here can move. You can see my lights are staying on. Hopefully you can see if the light's on. But then if I hold it here, which is the motor, and that wraps around to the circuit board, so now nothing past my finger can move. See how lights go out? I think one of these wires in this bundle is broke. Or partially broke. What Lemax does is these wires are actually colored. You can kind of see the coloring down here. It's also on the back side of the board. Or when this was open, probably couldn't see on the camera. The wires are red, black, yellow, pink, and gray or blue, depending on how old it is. And they paint them. They paint them white, so it doesn't look bad. This is before they started putting in the insulation off the switch that looks something like this, where it's insulated and all the wires run inside. So you can easily fray, break, or damage the strands because they're held together with paint and a little bit of almost like house caulking, white silicone caulking that you put on your windows or something, which is right here. It goes to right about there, and it's the stuff that's holding in this fuzz, and it goes through. And where it bends, like right here, or right here where it passes through, you can break or fray or crack one of the 5 wires, or 2 or 3 or all 5. So toss out this capacitor. Now, I need to see which one of the wires is possibly bad. So, first thing I'm going to do is lift this up, because this helps hold these wires in. And I'm going to pull the wires through to the inside where I have more play, so I can check this bundle right where it passes through. Where I'm going to try. Take me a second because I need to remove the remnants of the glue that's holding the bundle. I think I see the broken wire. It's right there. Alright, now let's see if I can get this to... There we go. So now I have the wires inside, and there is the broken wire. I'll zoom in here in just a second. I want to inspect the entire bundle first. It is 2 wires that are shorted together, just like what was underneath the circuit board. So the wires got frayed from rubbing and moving, and they've gone through the insulation, and now the bare wires are touching, which is creating a short, which is probably what blew the capacitor. It also could be the reason why we don't have sound, because this is also your volume knob. So if your volume is shorted out, you'll have no sound. Which also means it could have damaged the blob chip, because there's no fuses, there's no protection, so if you short something out, you can damage it permanently. Blob chips are very susceptible to it. The amplifier chip, not so much. Capacitors, they don't generally like to be discharged immediately through a short. They can pop, as the other one probably did. So I'm going to zoom in, try and show you the fray, show you the tracks, and I'll zoom back out, and we'll try and fix those wires. First, we'll just separate them and see if everything works. And then if they do, then we'll take care of the insulation issue. So, going down. So as you can see right there, that darkish stuff right there is the copper. There's no insulation like over here. Those are two different sets of wires. As I twist it, you should be able to see it better. And then I know it says motor, which is, that's what the M minus and M plus mean. And the capacitor comes off. The track on the bottom goes to the blob chip. And then the M plus, which this is attached to, also goes to the sound chip, which is right here. This is the amplifier chip. They probably do it so when the motor's on, the sound chip gets power, and this is the smoothing capacitor for the motor. So this probably popped, and when it popped, it can no longer smooth the motor's noise in the circuit. It could potentially have damaged this or backfed to the circuit board if the short that's over here isn't the main cause. And this is why you lose things. Oh, and you can see right here, because I show the capacitor symbol over here as well. Plus, minus, minus, motor plus. So here's your track. That's why this is the minus on the outside. Now this one had this symbol, but it did not have the plus and minus. Usually the thin solid bar is the minus, and the bigger fatter bar, in some cases is hollow, sometimes they fill it in, is the positive. And this would be a diode, just a regular diode, which I'm assuming is the reason why the diodes are soldered to the back of the motor, right? There's one there, and there's one over here. So both legs have a diode. So they didn't use the circuit board as it's designed, which could be maybe an update, or this circuit board used for multiple things. The speaker symbol, which is right here, the two wires are soldered from underneath and then go out. So they go out and over, and they're right here. That's the black wires right there under the gear. So they're soldered here and here from the bottom, not the top, where they run over. That way they don't get caught in the disc or that moving gear, because that would be bad. So, but a lot of circuit boards, when you lose a component, not all of them, they're labeled 27 k ohms, 220 k ohms, 10 microfarad, 220 microfarad, which is right here, it's just been moved, 8.2 ohms, which is that resistor there. Your 51 microfarad if they had a capacitor right here, which they don't. So a lot of times when you lose a component, depending on how they do the circuit board, especially these older ones, they're labeled. So you can replace them and know what you're looking for. So if you can't read the color codes on the resistors or the power on the capacitors, because let's say the casing blew off this plastic wrap, your circuit board can help you. And on these ceramic capacitors, like right here, when they go, you can't read them at all, because usually they burn the coating off, or they melt, or they split in half, which is the common ways I've seen them. They can fail like this one did, where they just fail, and then you can still read them. But if you have an older circuit board, because a new Lemax, they put the symbols on there, they don't put the values. So, and that's so you can't fix them yourself. So let's get these wires separated. and try this thing again. I'm going to use a screwdriver here to go in between the bundle and separate the two strings. There. So the two strings are separated. I'm just going to double check the other three real quick. They look okay. And no sound, no short. Oh, I guess you can see the glowing of the light, but there you go. There you go. So that's the problem. Now you can cut those and heat shrink them, and we'll solder them and then heat shrink them. Or you can try and wrap them in electrical tape, or you can use, and comes the camera, there we go, liquid tape. This is electrical tape, liquid that you brush on. So you brush on insulation. So you can use stuff like this too, which is probably what I'll use here. This one is from Dorman. It doesn't matter who you get them from. I got this at AutoZone, which is where most Dorman products are sold, just because I needed it for a car, and I do use it on these every once in a while. This stuff smells horrible. So if you have an enclosed room, it's going to make you cough. Actually, before I do all that, let's connect the motor and see if this gear spins. So first thing I'm going to do is move these out of the way of the gear. I'm going to touch the wire to the motor. It's noisy. It works. Kill the power. See if I can zoom out correctly. Nope, did it wrong again. Now, liquid electrical tape, I've only ever seen it in black. I've never seen it in white or green or any other color in the rainbow, because you can get electrical tape in any color you want, but liquid electrical tape is just the OG black color. What I'm doing is there's still glue on the wires. I'm trying to get the glue off. So I have just bare copper, like that. Before I liquid electrical tape it, just to make sure those strands are bonded good, because they are frayed, meaning they're no longer twisted anymore, they're just straight. To give them some strength, I am going to hit them with some solder, which will make them more rigid. And with them being more rigid, they'll bond better and hopefully not break. And then I'm going to coat them in liquid electrical tape. Man, am I having a problem making words today. And once we get this done, I'll message the person, because they just told me it didn't work. I didn't get any information that I can remember on this other than it didn't work. But the information that was sent to me on this was a long time ago. It's not that it's been sitting here, it's just he didn't send it right away. But I'll ask about the sound or what happened. I don't have any history on this piece. Sometimes history helps. Not always, but sometimes. So here is the nasty goop. Just stir it up a little bit. It's got a coating on the surface. This stuff does have a shelf life, so it will go bad and it will just turn into a big block of black rubber stuff. If you get this stuff on your hands, it will come off when you start shedding your skin. It's pretty permanent. There we go. Oh yeah. kind of smells like spray paint, paint thinner, and artificial flavoring all at the same time. I'm gonna let that dry. That way, when I pull the wires back through, it doesn't move the coating and cause it to, what do you want to say, peel off and cause the wires to be bare again. There's the patch. I am going to pull a little bit out of my way just so I can see height-wise this capacitor to the gear. Looks like it should be fine. So I'm going to let it pause. I think it takes like 15 minutes for this stuff to cure all the way. What does it say? 10 minutes. So I'm going to give it 10-15 minutes to make sure it's tacky before I go to the next step. And in the meantime, I'm going to message the person and ask them about some history. So maybe when I come back here in 15 minutes, I'll have some information. I'm also trying to figure out why the screen is so dark over here. At least it is on my end. Maybe not on yours. Maybe not. Well, where I'm sitting, it looks like it's just shadowy. Like there's more light in here than most people have in their house. So, anyhow, that's where we're at so far. We found the wires frayed. Motor not soldered. The wires in the back twisted, so I soldered those to give good connection. Loose switch. That's one of the reasons I took it apart, is because the switch was rattling because the screw had come out. And we have no sound and a blown capacitor. So that's where we're at. I'll be back in just a few. So one moment, please. All right, we're back, and it's back together. There's no sound still. The sound chip is bad, or excuse me, the blob chip is bad. I did have to move the capacitor. You can see there's the wire soldered on, and the cap's over there now. Doing some testing on it. I'm getting no voltage and or frequency out of the leg going to the chip, the amplifier chip. So when this thing got damaged, it took out the sound, which unfortunately is not fixable. So we do have lights in motion. Since I had the hot glue gun out to fix or glue the capacitor down, I glued the ring back on here. I also glued the lights back in that had fallen out. So that way, it's one less thing that has to be done. Alright, so let's put this thing back in, screw it down, and see what it looks like inside. The information I did get on this. Oh, I also glued these wires over here. The person that's I've been talking to, his sister bought this at a garage sale. And all the wires were cut and the bottom was hanging out. They did their best to try and fix it, but they had no luck in getting anything working whatsoever. So they had nothing. So it's gone from 100% non-functional when they got it at a garage sale to 2/3, which is motion and lights. A lot of the time when you lose sound, it'll never come back unless it's a bad speaker, and that's because the blob chip is, just like every other part of it, is sensitive to shorts and backfeeding. So when that capacitor blew, if it sent the wrong signal down that track, the power track to the amplifier, and it backfed the blob chip, it'll fry the sound leg of the blob chip. The amplifier chip just amplifies the sound so the speaker's loud. The blob chip has the predetermined soundtrack on it, which is why they're almost impossible to repair. So, screws are in. Beautiful. I'm going to kill some lights so we can see what this actually looks like in a darker setting. One light. Two light. Three light. And there you go. You can kind of see the chandelier up there. See light, the chandelier light right there through the top window. So, light's coming back. You can see if you watch carefully, you'll see the characters not only are spinning, but the characters are spinning in their platform. And if you remember how hard it was to take that plate off, that's because there was a piece of plastic on the disc that I popped off that was knurled over. Probably from when they put it on, they press it on and it caused a wrinkle in it. So I just trimmed that off and the plate goes on and off that center shaft easy now. Well, now you see how to work on this piece. If you lose your sound, there's a chance it won't come back. Unless it's in here, bad switch, or bad speaker. If something back feeds that bob chip, it's pretty much the end of the component, or that portion of it. So, we've gotten it from 100% non-functional to 66%, since it's only got three things. So the only part needed was a capacitor. Other than that, the gearbox was good. The LEDs all worked. They just weren't held in with their glue. And, well, the speaker ohm's okay, but just there's nothing going to it. Capacitors you can get on eBay or Amazon. I'll try and find a kit with some basic ones in there. The rest of it was just putting it back together with some hot glue and solder. I did chip away all the other glue, so when I glued the bottom on, that outer ring and the LEDs that had fallen out of the inside of the dome, I did remove the hard glue they used, which they didn't do a good job, because if it was done correctly I wouldn't be able to peel it off. But I did remove all that and then put a whole new bead of good old-fashioned hot glue, Sure Bonder brand. So, but there we go. Lemax Palace Ballroom. Pretty much as good as it's going to get for what's happened to it in its history. Well, thanks for watching. Until the next one.